Okay, so last time I was solving this problem, length of longest valid substring, but the problem is, the issue is that I didn't, so there was a solution based on a hash map, and I didn't resolve it, I didn't check it with Leetcode checker, and it turned out it had some issues inside. So the problem description is we have blacklisted words, and we have a long word. Blacklisted words are pretty short; they are maximum 10 characters, and the input word is actually 10 to the power 5 length. So we need to do what? We need to find maximum consig. We need to return the length of the longest sequence that doesn't have like forbidden words inside. So the first approach I suggested is based on the hash set. So the idea is that we add all the blocks list, all the forbidden words uh, to the hash set, and we also save mix and max length while we're doing that. Mix and max length for the forbidden word. And then I apply the sliding window approach. So I have a right pointer going through all like positions for the word, for this long word. And then what I try to do is I have also left pointer, and I will start trying the short word, the shortest like word that ends at R, and the shortest word like candidate should be like at least mean length lengths, because all the forbidden words are great lengths are greater than mean length. So I start there. So I check the word that ends substring that ends at R and that begins at I, where I is R minus mean length plus 1. And then I'll gradually will increment this suffix, um, holding the right position, and I'll increment the its length by decreasing the left or like I pointer. In this case, we have what? We have L already. Uh, this is L and R. This is the boundaries for the possible solutions, where we can find where we start looking for the blacklisted words, and they should be basically end at they should basically end in the end of their at R. So I do this, move the I pointer, I check while the I greater than Rmax length plus 1. So basically I have this condition for the maximum length of the blacklisted word, and then I should be greater than L. So this is uh, the space where we try to find the blacklisted word. The blacklisted word should add an at R, and then the space it occupies should be in between L and R. And we go for the every length greater than than mean length. We we do the substring for the candidate from I to R plus 1 not including, and then excluding, and then we check if the candidate is included in the blocked list or like blocked set. And if it's included, that it means that left pointer, you should move the left pointer, like the boundaries for all possible solutions that at R. So we move left pointer to I plus 1, meaning that from I to R, it's already like from I to R, including there is a block listed word, and it means in order to, because we were like increasing I, this the first block listed word, and we should just move the left pointer to I plus one, so that a block listed word, if it's there, it will be like it's like first part gonna be cut, like the prefix of one character gonna be cut, and then we're gonna try to find in that space the solution. And because the left pointer and right pointer, they are not covering all the blocked list, firstly found blocked word, then we can like update the result, and we can proceed like advance R and then do the same again. So that's the algorithm. Let me just. So there are a couple of mistakes in the old one that I showed. So I was using length here and was converting back and forth, and now I just using I as a kind of candidate left pointer. And then yeah, that's probably were all the mistakes I had in that video. And let's assume we run it. Oh, I was running in C++. So my sketch for this video was to convert from this convert from this hash set searching to the just to a tree structure, so that we advanced I, we save the words, block words in a reverse order in a try, and we advance I, we move the I that's left pointer for the candidates, and we just go through the try, and then in we check if it's blacklisted word or if it's end of word. If yes, it means that we found a blacklisted word. Yeah, so that's it. And the first time we found the end of word in a try, it means that it's our like we found our candidate is like blacklisted word, and we should basically advance L, and should be like whatever index left index of the blacklisted word plus one, and it's going to be the minimal blacklisted word that ends at R. And this one will save us some computations. We won't need to call this blocked contains candidate. We will just walk through the try, and we will save some like hash set calculations. We also do this substring here. We can like check in place for the try, and instead of like copying substring, because blocked contains, so we'll need to basically calculate the hash value for the string, in this case for the candidate string, and that will take the length of candidate time complexity. And for the try, we're gonna do the same. We're gonna go through the try character by character, starting from the right, and then we so it's gonna be the same O of n, where n is number of candidate candidate, but yeah, number of candidate, but also like max length of max length time complexity. So it's similar, but we don't have to do the substring, and that will save us some time. And also saving that in a hash set might be not efficient. Trie is more efficient for saving something like uh, blocked list of strings. So the try, I'm gonna start implementing the try here. So it should be public then we're gonna have public try node sub nodes equals new. So we have like 26 symbols in our alphabet, and then we have public boolean is end of word. False, and then we have public try node. And then we need to implement a couple of functions. First one is void add word to try. So we'll do the following. We'll do try node current equals root, and then we do for int I equals word length minus 1, I greater than equal 0, I minus minus, and then because I want to save the word in a try in a reversed order, so I do that current get if current get current word. So if it's equal null, it means we do that if current node index equals null, then we're gonna create now equals try node, and then car equal car subnodes index, and then current is an word equals true. That's it. Then we need to basically figure out the next function. So like initially I instead of hash set blocked, let's say blocked try, say try, and say try node, and then we do this one. We do this add, so add word to try, and then we do forbidden word, and then we'll have the blocked try truth. Then we're gonna go from the right to the left. Oh, from the right pointer gonna go from 0 to length, toward length, and basically I need to figure out if the if the um, if the our word and then if it contains blocked suffix, blocked contains blocked, and we'll have the integer left, integer right, and then we're gonna have word itself This is gonna be left and right pointers to the word. And then we're gonna have try node, um, let's say root, or current. Let's say, okay, let's call it root. And then we do the same. Okay, so let's continue. Mm, So we need to figure out how to do this, if the how to write this function if the past substring, or like how we define the substring based on the word input, or like source and the left and right pointer, if the past substrings reverse of it is included into the tree node. So I'll do this tree node current equals root, and then I'll do while current not equal null, and then I'll do this. So in the case we in the case it's not included into the tree try, I wanna return -1. In case it is included, I wanna return the length of it, of yeah, the length of it. So basically, in the try we have a bunch of um, we have a bunch of um, blocked words. Let's say we have um, for this case we have CBBA, BCA, CBB. Okay, so let's copy this one. So for the try here, if we do reversed order, the try for this one gonna be, we have under root, we have A, B, and C, and then let's start with this one. We have next C, and we have next A, and oh no, B. We have B here because it's reversed, and the one that's A. So we have also here B, then we have B, and then we have B, and then we have all the way down, and then we have A. And that's gonna be like the node below gonna have this end flag, end of word. This one also gonna have end of word. And then we're gonna have C, okay, B, 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 then we have B, and then we have A, we have A, and here we have end of word flag. And then we'll have the last one, this word C, then C again, then B, then C, and then we'll have A. It's gonna be end of word. So in this case, we're gonna pass CBBA. Let's say CBB. How many B's? 3 or 3A. Three B's and one A. And then let's say we have like left pointer pointing here, right pointer pointing here, and we need to figure out within this boundaries between left and right, do we have any what's the smallest blocked word that ends like with A. So the smallest one, say we have A A B B B A. The smallest one gonna be we're gonna go walk from the end of this word or from the like the R pointing to and do up to the L, but we might escape earlier. So we have A we go here. We have another A, we go nowhere. Yes. So we in this case there is no path to follow. It means that there is no uh, block listed word that ends with double A. It means that uh, or any other combination. Uh, like I mean like there is no block listed word that ends with double A. It means that and there is no block listed word that ends. So basically, we should return case minus one. Let's say we have B, B, A, and then F. We walk through our um, try, and then we'll have the B, B, A, and end of the word. And in this case, we need to return positive value, and it's gonna be the length of the shortest blocked word that our uh, window ends with. So it's gonna be length gonna be 4 this output. So in this case, you need to walk through that one, and then for the current, let's say current equals root, and then uh, current equals root, oh current, and then we need to find the character, or like let's say word char at, and then we need to do. Okay, let's do this I. I guess it's gonna be better. I equals R, while I greater or equal L, and then int I equals, let's say R, while I minus greater than, let's do that in the end. I minus word chart at uh, chart at I minus A uh, minus A, and that's gonna be the index. And then we need to do this current subnodes index is gonna be the next current, and then we need to check if current is end of word. That means that we need to return the length. Return L R minus I plus 1. And then we're gonna go this index. That's about it. So let's say the uh, current not equal null. Can there be like empty words right away? Let's assume we don't have like empty words. Otherwise, I can like return like do this. Oh, I can do this check if root is end of word, then return 0. Mm. But this gonna be, yeah, this gonna be like just here. We're gonna go there and we're gonna return. Uh, I'm gonna return 1 actually in this case. Mm, how to think about this? Let me think. So if you start from the root and it already has end of word flag, let's say we go here. Ah, okay, so r minus I. So here gonna be r minus I. So usually, if we go from here to there, it's basically just one step. Um, so at here we have like I equals like 0, the index, um, but like the actual information for that character is like here because like uh, gonna be special end of word, the same like as here. Like this end of word will not include will not be included in this array, but are gonna be included in the child array. So we're gonna be end of word here, and then gonna be end of word here, and gonna be end of word here. Because for the A, actually, here, this is if this is the array of child nodes, subnodes. For the A here, we'll have a tree node here, but it will have empty subnodes. So basically, we need to do this r minus I, uh, yeah, r minus I. And then we need to do this car is end of word. Something like that. So for this one, we need to go through the maxlen. Okay, we'll have the maxlen here. Add word to the try. Then you have result 0, word length I, and then we basically need to check um, int lang equals. contains blocked, and then we need to check. Okay, so we need just instead of doing this checks, we need just in len equals contains blocked, and then we need to pass left, right, and then we need to pass word, and then we need to pass blocked try root, and then if len not equal -1, then we need to update the l equals r minus l plus 1. Minus len. Yeah, this one. This is the updated algorithm. Let's update this. Left right equals 0. Check it out. And we don't even need to have this max len because it's gonna be more or less efficient. This walks through the try. Output equals 5. So let's try to figure out, do we have like r minus 1 minus I plus 1? I initially is equal r. Let's try to figure out. Even bigger. So we have right and left pointers here. Okay, let's start printing out. Okay, that's it. Let's test it with Leetcode. Mm,
So let's continue checking what we have there. Oh, okay. So um so we have this if and of word. I have a few test examples failing here and there. Let me quickly check what is failing and why. So we have AA, 3 A's and CB. And this one case okay, let's continue debugging this one. So in this case we have this C input and So the word equals this one, forbidden equals AACB. So for the tree, we'll have CAs and the BC tree, or trie. Let's maybe write it. Now let me think about this. The trie, how it's gonna be built. So we start from the end and we go up to the beginning for every word in a forbidden, and we get the index by basically getting the character and subtracting a from it, and then we check if the current subnode's index is null. We create it, and then in the end we reassign it, and then in the end if you go to the up to the last character, you'll have if end of word equals true flag. So I assume the issue is either here or here. So let's check. So we have word length. So R is going from the beginning to the end, and then we have if contains blocks, so like from L to R, and here is E I greater than L, from 0 to 0 I greater than L, current not equal null. So you have this word, say so I equals okay, L equals 0, R equals 0, so I equals 0. We check. So we start from R equals 0. We check the contains blocked from L to R. So we need, if we have like end of word first occurrence, we need to subtract to get the length. Let's say that I equals, let's say 9 and R equals 10. Oh, this was a valid one. If end of word. Because I'm gonna have like extra one. Yes. So let's say we have like 1. So the idea is that I need to somehow figure out how many, what's the length, what's the minimum length of the, what the maximum, kind of, if we see the blocked word in the word, the first time we see that, and it has a minimum length out of all the blocked words, if you see that in the word, like starting from the end, we should return that length. -1. Yeah, this one seems okay. Here we have, I guess, this one. Okay. Hmm. Okay, let's unlock it. Hmm. So this one function should return the length um, of the shortest blocking word, like blocked word, or -1 if no blocking word is in suffix of word. So it should return the length of it. Yeah, and it currently returns the length. In this case, if the length is not -1, you need to do this +2. So let's say we have the longest word, so that like the length of blocked, so the let's say 1, 2, 8 minus 2, okay. Yeah, it seems like unless until I specified the what this function does, I was like in between. In one place, I was I was thinking that this one returns like the valid the last valid suffix length, and the other one other times I thought that it returns the shortest blocked word and the shortest blacklisted word. It's hard here. The subword, shortest blocked suffix of word, something like that. And because of this like two definitions, I wasn't able to I was mixing them together, and that's why I was not able to correctly specify this function. But now this function contains blocked. It either returns -1 if there is no valid suffix in a word that's included into the trie. Otherwise, if there is a suffix that's included, or like many suffixes that included into the word in the window from L to R, and that suffix is actually in a blocked or forbidden words list. I wanna return the shortest length for that blocked word suffix. And when I return it, when I see that it's not -1, I just like make it a little bit shorter, so I know for sure that it's not in the blocked list, because I have returned the blocked list length in this case. Blocked the shortest blocked word that's current word from L to R ends with. Oh, output limit exceeded. Ah, okay. It's because I'm doing this one. Okay. Noted. So I managed to do that within 58 minutes. Let me quickly check what they have here. Try also. So that's probably it. I checked a couple of solutions here, and it seems like by memory it's not a good. For memory, my solution is not that good. But if I check there, it seems like it's hash set solution that are good for memory here. Yeah, I'm gonna wrap up here, and so that's it.